Alright, so today we are going to be talking about triangles and its formula. So does anybody remember what the formula is to find the area of a triangle before we get into this lesson? If you don't remember, is there a way that you can figure it out? Where can you look in your notebook to help you out? Anybody know? Where can you look in your notebook to see if you can find it? Aiden? In your what? Yes, you can look in your flip book. So if you don't remember the formula for the area of a triangle, please turn in your notebook back to your flip book and see if you can figure out what the formula is. Once you have it, please raise your hand. So once you have found the formula, please raise your hand. That is what you're supposed to be doing. Raise your hand, Emily. Raise your hand, Emily. Mikhail, are you on this page? Because this is where you should be if your hand is not raised and you don't know the formula. So if you're not sure where you're supposed to be in your notebook right now, you're supposed to be right here, flipped up to the triangle page. Alright, Cooper, what is the formula to find the area of triangle?
Base times height divided by 2.
Base times height divided by 2. Can you also say it another way?
So what now?
Can you also, like, say it a different way?
The area equals base times height divided by 2.
What's the other way that was written in your foldable?
Area equals half base times height.
Right. So, and the reason why I'm putting both of these on the top of the page is because ultimately I want you to use whatever you're most comfortable with. If this is what you like and this is what you want to use, absolutely. If you kind of like this and you want to try it, go ahead. But I want you to have both options. Yes, ma'am?
Didn't you say 7? Where's lesson 8?
We don't do every single lesson. Because, like, we spent how many days on parallelograms? If I had to look at another parallelogram, I might throw up. Like, I was tired of them. I feel like we need to move on. I feel like, for the most part, we have a fairly good understanding of parallelograms. So, there will be times, guys, that we do not do every single lesson in every single unit. So, that's why I don't have you, like, label all the pages for every unit. Alright, so let's go ahead and get started with our warm-up. So looking at 9.1, bases and heights of triangles. It says, study the examples and non-examples of bases and heights in a triangle. Answer the questions that follow. Alright, so it says these dashed segments represent heights of the right triangle. So the dashed segments are what to the base of each one of those triangles up here? What kind of line do they form? Delilah. They're forming that perpendicular line, so you have your right angle somewhere around there. So the base and the height must form a perpendicular line. Alright, please make sure you write that down. And then the dash segments for the bottom three does not represent the height of the triangle. Alright, so the dash segment for this one is along that side. It's just really hard to see. So I just kind of added it in. Give me a thumbs up when you have this written down to the side. Alright, so you're using the set of examples and non-examples to answer these 7 questions. So essentially you're selecting all the statements that are true about bases and heights and triangles. So you're going to circle 1, 2, 3, 4, 5, 6, 7, whichever ones you feel like are true to go with the correct way of identifying the base and the height. Does that make sense? Alright, I'm going to give you 2 to 3 minutes. If you finish before the timer goes off, please just stand up. Go ahead and get started. You're not talking, this is quiet work time. so we are gonna do the whole stand up, sit down kind of thing for, which ones we think. We are gonna do the stand up, sit down thing for which ones we think go with the correct statements and which ones do not. Alright, so stand up if you said that any side of a triangle can be a base. Alright, that one is true. So it doesn't matter which side we make the base on the triangle as long as it's what to the height. Raise your hand and tell me, as long as it is what to the height?
Perpendicular.
Yes, as long as your height is perpendicular to your base. So as long as you're forming that right angle, it does not matter where your base is identified as. Alright, so stand up if there is only one possible height. So we said no. Why do we say that this is not true? Ronnie?
Because I think yesterday, like the day before, we had these triangles that had, or no, two parallelograms, and they had two different heights. It was like
Remove yourself until you're ready to be in here. Go ahead. Yep.
it was like
Don't
10
take anything. Hold on. Don't take anything just until you're ready to focus and stop bothering everybody around you. Yes, I'm sorry.
I think it was like 10 or 15 and 8. You had to figure out which one was the height between them.
And the other thing is, if you're looking at your examples over here, guys, remember, with parallelograms as well as triangles, you can have your height all the way down. You can have it inside of your parallelogram, or for example here, you can have it on the majority of the outside, as long as it forms what to the base?
Right angle.
Right angles or perpendicular lines, okay? Alright, so 2 is not true. Alright, number 3, it says a height is always one of the sides of a triangle. Stand up if you think that is true. Okay, alright, so let's talk about our examples again. So, looking at the ones that are correct examples, are they the side? Troy? Alright, so this is your base right here, this is your height. This is your base right here, this is your height, this is your base right here, this is your height. So do they have to be on one of the sides? No. Now, this one, you could say if your right angle triangle is a straight, I guess a straight right angle, I don't even know what that would sound like, that just seems weird. But essentially if your triangle looked like this, and your height was here and your base was there, then yes, it would be a side, but it doesn't have to be a side of your triangle. Does that make sense to you guys? Alright, so that one is not true. Alright, number 4, it says a height that corresponds to a base must be drawn at an acute angle to the base. Stand up if you said this is true. Why are y'all looking around? Stand up if you circled it. It doesn't matter if you're the only one standing. If you think it's true, stand up. Okay, I have a question. If it is corresponding to the base, what type of line does it have to be? Perpendicular. Alright, so that is not true. It does not, you don't want it to be an acute angle, which is a small baby angle under 90 degrees. You want it to be a 90-degree angle. Okay, slide over to number 5. It says the height that corresponds to a base must be drawn at a right angle to the base. Okay, this is true. Because like I said, all of these are forming right angles to the base, correct? Alright, number 6 says once we choose a base, there is only one segment that represents the corresponding height. So stand up if you think this is true. Why not? Why is this one not true? So what other than Roddy? Why is this not true, guys? Why didn't you pick it? Mikhail?
So in the examples, it says these dashed segments represent heights of the triangle. But in the first one, there's 3 dashed segments instead of just one that
Right. So essentially, again, as long as you are forming a perpendicular line to the base, your base can, or your height can be represented anywhere along that, the tip of the triangle, anywhere along your base. Does that make sense? And number 7, it says a segment representing a height must go through a vertex. Stand up if you think this is true. All right, so refresh my memory because I have forgotten. What does the word vertex mean? I don't need to know that you don't know. I just simply need you to raise your hand if you think you do know.
Is that the corner of a shape?
Right, so it's essentially the point. So it's saying that every height must go through this point on your triangle. Is that true? No, again, because we have this first example that's got the heights all the way down it. So the only 2 that were actually true over here were number 1 and number 5. Okay, so good job to those of you who got number 1 and number 5 correct. And hopefully those of you who picked a few other ones, you understand why they didn't work. So before we go any further, I want to ask you, do you see similarities between triangles and parallelograms? Who said yes? What's the similarities?
With some parallelograms, if you like,
I'm not talking about the shape. Obviously a triangle is very different looking from a parallelogram. What I'm talking about are the characteristics. Ethan, what do you think?
any side of a parallelogram and a triangle can be a base.
Okay, so any side of a parallelogram and a triangle can be a base. Very good. All right, what else? The height and the base for your parallelograms and your triangles must form a perpendicular line. All right, anything else? Can the height be extended outside of both of those shapes?
Yes.
Yes, it can. All right, so they're actually, even though they don't look the same, they're actually very similar, okay, characteristic-wise. All right, let's go on to the next activity. So it says finding the formula for the area of a triangle. For each triangle, label a side that can be used as the base and a segment showing its corresponding height. Record the measurements for the base and height in the table and find the use of the triangle. Find the area of the triangle. The side length of each square is 1 unit, just so you know. And then in the last row, we're going to write an expression for the area of a triangle using base and height. So flip your paper over. So these are the 4 triangles that they are talking about. So we are going to do the first one together. Grab a different color. All right, where do we want to label the base? And let's try to keep this as easy as possible. Where do we want to label the base? Troy? Okay, so this is going to be our base. All right, and to find out what our base equals, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our base equals 10. All right, and then they've kind of already labeled our height if you look really, really closely. The height that they labeled was right here. All right, and what has to form in order for us to know that that is our height to the base of our triangle? Delilah? Yeah, so we know that this is going to be our perpendicular line. So this is going to be our height. And we're going to count 1, 2, 3, 4, 5, 6, 7. Okay? So in our table, our base was 10, our height was 7, but what do we have to do because it is a triangle? What do we have to do, Cooper? We have to divide by 2. So remember, this line right here kind of means multiply. So 10 times 7 equals what? 70. And then I'm going to do 70 divided by 2. What can I multiply 2 by to get 7 or close to 7 without going over? Ethan? 3. And then what can I multiply 2 by to get 10? Aiden? 5. So our answer is 35 units squared. And I'm going to put in parentheses, divide by 2. Just so we don't forget that. All right, as a group, you guys are doing B, C, and D. Okay, I'm going to give you about 7 minutes. If you have any questions, please raise your hand. We will go over them when we're done. Hold on, listen. Shh. You may identify the base and the height with your color. If you're not sure about it, I wouldn't do it with a color. I would just use a pencil, and then when we go over it, you can use a color then. But if you're 100% sure you know what you're doing, then you may use your color.
Hi.
All right, go ahead.
What's the height? The height is 6. Base is 6. Okay, now we got 6. Divided by 2. Divided by 2. It's either 9 or 9. I think it's 9. I think it's 4. I have absolutely yeah, I have absolutely what's the Wait, is it not just 50?
Make sure conversations are where they're supposed to be because they are not.
This time would be less than 9 or less than 9. This has to be less than 8 or less than 9.
This is less than 9. We already had this conversation, y'all. Like, we're not going to do every single lesson from every single unit. So, like, we might skip around a little bit because either we don't need that lesson or that lesson is like going to help you guys. Alright, y'all. Let's go ahead and go over this. Alright. Let's go over this. So looking at B, which one are we going to identify as the base? Start with that. Which one do we identify? Ethan. So this one has your base? Okay. And what did your base equal?
Our base equals 10.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Oh,
Okay. Alright, so our base equals 11, and then which one is going to be our height if that is our base? Which one's going to be the height? Isabella. Which one is going to be the height though? Which one is it? Guys, stop talking please. The left side. So this is going to be our height, and we know that because it's forming that perpendicular line. So this is our height, and you said 6. 1, 2, 3, 4, 5, 6. Alright, so our base was 11 times 6, and we have to remember that we have to divide by 2. So what is 11? Sorry, you can't see that. What is 11 times 6?
66.
It is 66, and then we're going to divide it by 2. Raise your hand and tell me what do we get when we divide by 2. Noah? Not just 33, but unit squared. Good job. Alright, looking at C, which one did you identify as your base? Which one did you identify as your base? Troy?
We did 10, and
on the bottom. So this is gonna be our base. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Alright, so if this is our base, guys, it's important that we know that we can extend outside of our shape to make sure we get that height. Don't try to figure it out from here. You should have identified your height as right here, and that forms your 90-degree angle. How many of us did that? Okay, if you did not, that's where your height should be for this one. Or like anywhere along this line, technically, you can have your height, but that's the easiest one to see. All right, so what is our height equal for that shape? Mikhail? 3. So 10 times 3, and again, we have to remember we're dividing by 2. All right, so what is 10 times 3? Aiden?
70.
And then I divide that by 2?
To get 15 units squared.
Perfect. Okay, and the last one, D. All right, where are we going to step outside because you're clearly not ready to be in my class anymore? Where are we gonna label the base for D? Emmeline, where'd your group label the base for D? On the top, okay, so this is our base. What is the number, like what's the measurement of your base?
4.
So we have 4 there. All right, and then Emmeline, where did you guys label your height?
Where that line?
So from right here?
Yeah.
Okay. All right, and how do you know that you can use that line?
It's perpendicular to the base.
Perfect. And then what was the measurement for that line for your height?
11.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. All right, so our base was 4 times 11. And then again, we have to remember to divide by 2. So what is 4 times 11, Cooper? And I divide that by 2, Cooper, and what do I get? Perfect. All right, so the last line of your table, again, we're doing base times height divided by 2. So B times H divided by 2. All right, so how was that, excuse me, labeling the base and the height? Was it easy? Was it hard? Give me some feedback on that. All right, Kylie?
It was easy.
Why? Did you have any prior knowledge that helped you?
Yeah. Yeah.
What prior knowledge did you have that helped you be able to identify some of these heights?
I look for perpendicular lines.
So really studying perpendicular lines and really talking about perpendicular lines for the last like 18,000 years, I feel like hopefully it has sunk in a little bit for you guys. All right, slide over to the last activity over here. All right, and it says for each triangle, circle a base measurement that you can use to find the area of the triangle. Then find the area of any 3 triangles. So what that means is you're identifying the base on each one of these. So use your color to circle that one. So like for example, this first one, where would our base be on A? Where would our base be? For A, where would our base be? Raise your hand. William.
On the bottom at 5 centimeters.
Right, so our base for this one would be 5 centimeters. All right, that is what you're doing for A, B, C, D, E. Then you are picking 3 to solve. I don't care which 3 you pick, but you're picking 3 of them. All right, since we are a bit chatty today, we are actually gonna do this on our own. All right, depending on how well we're working on our own, I might give you like 2 minutes just compare our answers, but we were a little bit too chatty today on things that were not on topic. All right, so 4 minutes, go. Alright, take 2 minutes then and just kinda compare your answers and what you guys came up with your teammates.
No, she said you only live yeah, you were only supposed to I labeled that house to solve. I told Girl, the map is all around you. What do you mean? Yeah. I'm a okay, so you saw yeah. I don't know
Alright, so let's bring it back together. Let's go over these. So A, obviously we did together by identifying the base. How many of you guys found the area for triangle A? Alright, so what did you do, Kylie?
I did the base times the height.
Okay, so what did you do?
Oh, I did 5. I did the bottom.
Tell me
So,
the numbers, please.
5 centimeters.
Thank you.
And then the height, which is 6 centimeters.
Okay.
And then I multiplied that, and then divided it by 2.
Okay, so what did you get when you multiplied 5 times 6?
30.
And then you did 30 divided by 2, which gives you what?
15 centimeters squared.
Perfect. Alright, so looking at B, which one are we identifying as the height? Which one? Zoe.
On this side.
Left side?
Left side, yeah.
Left side. Okay, so this is gonna be our base. Alright, so Zoe, what, walk me through how to solve this.
Multiply 4 times 4,
Okay?
and then 4 times 4 is 16,
Okay?
divided by 2. You get 8.
Just 8 or?
8 centimeters squared,
Perfect.
and then that's your answer.
Awesome. Good job. Alright, the next one. So this one's a little bit more difficult. So, what number did we identify as the base? Noah. 7. Alright, and Noah, walk me through solving this problem.
Centimeters of the height, 15, and 7 times 3 is 1 divided by 2 is, I don't know if that is that one. But you should do that and then you get rid.
Yeah, and that's fine. So when you do 21 divided by 2, you get 10.5 centimeters squared. So good job. All right, looking at D, it says, well, actually, we have a plethora of interesting numbers on this one. So which one is our base? Which one is our base? Delilah. You want to use 8? All right, so what numbers did you multiply then? Okay.
And
Actually, hold on. 24. Alright, so that's gonna equal 28. And then what do we
That
do?
would be 28 divided by 2.
Okay,
And then 28 divided by 2 equals. I'm gonna say 8 because of my,
14.
yeah,
14 what?
14 is good. I'm assuming you're scared.
There we go. Alright, good job. And then the last one. Again, we have a couple extra numbers. Oh, wait, hold on, I have a question, Joanna. Why did you not use 8 and 73/100 centimeters? Right. So we don't use that one. Alright, and the last one. Alright, Cooper.
Alright, for the base, I use 6.
Okay?
And then for the height, I use 5.
Okay?
And then so, you do 5 times 6 is 30. And then you divide it by 2. 15 centimeters cubed.
And Cooper, why did you not use the 10 centimeters over here?
It's left.
Alright. Good job, guys. I know this was kind of a simple lesson, but I hope just the practice of using the formula and whatnot helps you out. So please go ahead, fold it in half. You're going to put glue. Everyone pay attention to this so you don't glue it wrong. You're going to put glue down here about the summary. So you put your glue here, and then you're just going to glue it down at the bottom. And that way you can open up the little page. Stop talking. Alright, when you get your cool down, please, 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 please read the directions. We are missing questions because we are not reading the directions carefully. Please put your first name, last name, date, and period on this, even if you're gonna come in later. Make sure you show all of your work. Make sure you do what it says, okay? I don't know how to tell y'all how to just read the directions. When you are finished, please turn this into the first period bend and then work on your Imagine Math lessons. If you are done with Imagine Math, you may work on Lexia. If you are done with Lexia and you have makeup work, you may work on your makeup work. Yes, sir.
Is it 3 or 4 lessons?
All right, get going. Got a couple of different things you can do.